For the human spaceflight programs and for many of the robotic spaceflight programs, the MMOD risk is defined by the Hypervelocity Impact Technology Group at JSC. And defining the risk and then trying to mitigate the risk is an iterative process. There's an application that will take several inputs that include the orbital debris environment, the micrometeoroid environment. There are models for those. It will take the configuration of the spacecraft, what the shields in the spacecraft and what the exposed components are made out of, and it will produce a risk number, which is a probability of micrometeoroids doing damage to your spacecraft. And you would get a probability, you would look at that, and then you would evaluate what you could do to change that. What different types of shields could we use? Let's try a different shield. Let's try adding some blankets, and you'll modify the configuration. There's a finite element model that gives a very detailed configuration of the spacecraft that's being evaluated. You stick it back into the risk application, and you would come back with a probability, and you'd compare that probability to what your requirement is. If you're meeting your requirement, then you can go ahead and proceed with the design or whatever you're planning on doing. If you're not meeting the requirement, as I say, you can iterate again. You can look at different aspects of the risk process. Now, this is at the design side. Different mitigations you can do from design. You can add more shielding, like I've talked about. There's also operational mitigations. If you have a particularly sensitive component on the spacecraft, say a propulsion tank, for example, and it's in what's called the ram direction, which means it's on the front of the spacecraft as it's going in orbit. Well, that component is going to get hit by the majority of the orbital debris. And if you have the flexibility in your mission to maybe change the attitude of that spacecraft and turn it so that you have something that's not quite as sensitive in that ram direction, that can also help you buy down your risk. If you have flexibility to go to maybe a different orbit, possibly a lower orbit will have a lower flux of orbital debris. That's also another option that can be looked at.